Hello and welcome to my YouTube channel. Today we are going to see how to blink the onboard LED of Tiva C board using TivaWare libraries, and for this we will be using Code Composer Studio. So first of all, briefly let us talk about the Tiva C board. Tiva C board mainly comprises of TM4C123GH6PM microcontroller. Here is the microcontroller in the center, and this microcontroller comprises of 80 megahertz clock frequency, 256 kilobyte of flash, 32 kilobyte of SRAM, 2 kilobyte of EEPROM, 2 CAN network bus modules, USB 2.0. It provides you 12-bit ADCs and motion controls for PWM operations. It also provides 8 UART modules, 6 I2C module and 4 SPI modules for communication. And it also provides an onboard in-circuit debug interface, which is shown here on the top. Okay, so these are the features of the Tiva C board. Now let us briefly look at the schematic and try to understand which pins to be used for this particular project. So the Tiva C board by default provides you two switches, SW1 and SW2, which are connected to ports F0 pin and port F4 pin. Then we have three LEDs, PF1, PF2, PF3, which are connected to red LED, blue LED and green LED. So if we have to blink an LED, we have to first choose one of these ports and then we will have to blink the LED on that particular pin. So to know the steps to blink an LED on Tiva C board, first of all we will have to provide the clock to the clock gating circuit of the port. Here in our case, the port is port F, because the red, blue and green LEDs of the Tiva C board are connected to port F. Then we will have to configure the pins of the port as an output pin, because we are using LED and LED is an output device. Therefore, we will have to configure it as an output pin. Second, we will have to configure the pin to work in digital mode, because the LED is going to switch on and off. So this is a digital operation. We are not using analog operation. We are not using ADC or DAC for this purpose. Therefore, we will be using digital mode. Then we will have to make the pin high, generate a delay so that the pin will remain high for some time, and then make the pin low and then again generate a delay so that the pin will remain low for a certain time period. So in this way, if we keep on repeating the step number 4 to 7, that is making it high, delay, low, delay, then again high, delay, low, delay for infinite time, then in that case the LED will be blinking for infinite time period. So let us try to write a code to meet all the requirements of step 1 to 8 in the Code Composer Studio IDE. Let's go to the Code Composer Studio. So when you open the Code Composer Studio, it will ask for a directory where you want to create your workspace. In my case, I have used desktop Code Composer Studio workspace. You can create your own folder anywhere you like by using browse button and create a folder, and then in that folder the workspace will be created. Now launch the Code Composer Studio. In my case, I am using the version 12, which is the latest version of Code Composer Studio. Once the Code Composer Studio is open, we can create the project by selecting Start New Project or by going to File, New and CCS Project. So these are the two options to create a new project. So I will click New Project, and here first I will have to select the target. So the target in the Tiva C board is the microcontroller. So the microcontroller is TM4C123GH6PM. So we will select this particular microcontroller. Then we will have to provide the connection. Connection means the way you want to debug the microcontroller or to establish the connection between the PC and the board. So for that we are using Stellaris in circuit debug interface. Click on that. Now give a name to the project. Let me give it blink LED, and then select empty project with main. That's all, and finish the project. So it will create the project with blank statement. So here we have int main void return 0 and all. So let us first build the project. So in the top you can see a hammer. Click on that and check if the build is successful or not. So here we can see the build is finished. On the right here in the problems, we can see there is no such problem here. So 0 items, so no problems in compiling the project. So now we can start writing the project or writing the code for the project. Before that, we will have to include certain files and folders so that we can access the TivaWare in Code Composer Studio. For that, just right click on the blink LED project, go to properties, and then go down to preprocessor options, go down further, include options, and here click add. So we are going to add the folder which contains the TivaWare. Now we will have to select the folder. So click browse. In the last video I showed you how to install the TivaWare, and the default path for TivaWare is in the C drive TI. Open that folder, go down and select the TivaWare C series 2.2.0.295. I have showed how to install this TivaWare in my previous video. Now go to driver lib. No, okay, just keep on TivaWare C folder, select this folder and select folder. So C TI TivaWare C series 2.2.0.295. Okay, and then apply and close. So we have added the folder to the project. Now second step is to add the driver libraries. So right click on the blink LED project, go to properties. Go to right click, add files, and in the C drive we have the TI TivaWare. Open that folder, go to driver lib. Here we will find the library files, or because we are using Code Composer Studio, open the CCS folder, debug, and here you can see driver lib.lib. So select this file and open. Now you will encounter this message which says select how file should be imported into the project. Either you can copy the file or link to the file. Better copy the file so that this file will be copied to your project. Otherwise, if you don't want to copy the file, you can select link to files. In my case, I am just going for copy files. Both options will work. Okay. So now here you can see in the project Explorer, you can see we have added the driverlib.lib file. Now we can start writing the code and access all the files and folders for our project. So let us start the code. Include st. Now after just writing few alphabets, you can use control space, which will give you all the options which are available. Okay, so standard int.h, then hash I, control space, you can go for include. Then we need a standard bool.h, then hash include. For autofilling, remember press control space. Now inc, and we need the hardware memory map of the microcontroller board. So hardware mem control space, we get memory map dot h. Now again include driver lib, and we now need debug.h. Okay, debug.h, then include driver lib. Because we are going to use GPIO pins, general purpose input output pins, so we will be adding GPIO.h file to access the features of GPIO. And because we want to provide the clock to the port, we will need sysctl. Okay, so for that, hash include driver lib sysctl.h. So for this project, because we are going to blink the LED, we need basically these two files, gpio.h and sysctl.h. These two files are required. Okay. Now let us start writing the code. So first of all, we have to provide the clock to the port. For that, we have to use the sysctl peripheral. So to access all the functions of sysctl, we have to know which are the functions available in the sysctl.h. Let us go to view, go to outline. In the outline, you can see all the h files or header files added in the project. So let me repeat the step. Close the outline window, go to view, come down to outline. In this window, you will be able to see all the header files which are used in the project. Now the question is how to get the functions which are available for sysctl, which are provided by the TivaWare. So I will right click on the project, go to add files. Here I will go to the TivaWare folder. Okay. Let me show you again. In the TivaWare C, go down and driver lib. Here you will be able to see all the .c files and h files for the TivaWare. So we are interested in the sysctl.c. So I will add this file. So let me copy it. Then right click, add files, and add the gpio.c, because we are interested in GPIO and sysctl. Now to know the functions which are available with sysctl.c, just click on the sysctl.c, and here on the right window, outline window, you can see all the functions which are available to be used for sysctl. Now let us continue with the main file. So first thing we wanted to do is to provide the clock to the port F. So let us use the sysctl.c file, go to the bottom, and let's check which function will provide the function to provide the clock to port. So sysctl down, and here must be sysctl, okay, peripheral enable. This function we will have to use. So let us go up and read about this function. This function enables a peripheral parameter or param, or UI32 peripheral is the peripheral to be enabled. So which are the peripherals which can be enabled using this function? Here you have the list of the peripherals which can be enabled using this function. So we are interested in GPIO F. So let us check if it is available here. Here we can see sysctl peripheral GPIO F. So we can enable the peripheral or port F using this function. So just copy this and paste it here, Control V, and add a semicolon. Now the question is how to know the name of the peripheral. Okay, so for that you can just delete this part, and we now have to add the argument for this function. So go to the sysctl, go up, and this is the peripheral which can be used in that argument. So Control C and paste it. So in this way it makes our life a bit simple for writing the code. Now let us use a function to check if the peripheral is ready or not. So I will use a while not, that means if till the function the peripheral is enabled, we have to wait here. So let us go to the sysctl and check if the function is there for checking if the peripheral is ready or not. So this is the function sysctl peripheral ready. So what this function will do? It determines if the peripheral is ready or not. Okay, so we will use this function, Control C and Control V. Okay, now coming to the argument of this function. So we need to provide the argument here. So which peripheral we are looking for? We are looking for the sysctl peripheral GPIO F. Just copy and paste it here, and wait here in this function till the peripheral is ready. So we have used while not ready, remain in this while loop, and when the peripheral will be ready, we will come out of the loop. Next step is to make the pin or declare the pin as an output. So for that, we can go to the gpio.c file and check which are the functions to make a particular GPIO output. Okay, so here we have to go down GPIO pin type, GPIO pin type. Let me just make it a bit bigger. So GPIO pin type and GPIO output. So we will have to use this function to make a particular pin high. So let us read about this function. This function configures the pin for use as GPIO output. And what are the parameters? First parameter is the base address of the GPIO port. Second parameter is the pin that we want to configure as output. So let us take this function, copy it, and in the main, let us paste it here. Put a semicolon. Now for the first argument, which is the port. So let us go up and check how can we know the port's base. Okay, so for that, the first parameter is here. UI32 port is the base address of the GPIO port. So we know the base address is port F. So GPIO underscores base GPIO underscore. So now you can see my board on the top right, and I can go for flash. This is one option. This will load the code directly and run, and it will not be, we will not be able to check if the code is going to run step by step. So let us go to debug mode so that we can see the effect of the program step by step. Click on the debug button and it will say blink LED main.c. OK. And we will be entering into the debug window. This will take few seconds. And now we can see we are at the debug window and our microcontroller or the program is waiting here. The arrow we can see here, Cortex M4 debug call stack. Here we are waiting. And to use the debug window, we can go for step by step. So in the top, you can see step into, or you can use F5. If you want to escape or skip some functions, you can go step over or step return. So let me go step by step. So first line, so we have created a variable count. And now our program is waiting in this line. Next, next, and we can skip these functions and let us return to the main program. And now let's go to the GPIO F. We are declaring it as an output. So again, it entered into the function here. You can skip it and come back to the main program. Okay. So lots of functions are there. Okay. Now we are here at GPIO write and you can see the LED is off. So after executing this line, we'll be able to make the LED on. Let us check. So we can see the green LED is on. And now we have the delay here. Let us run the delay function. And we can see here on the right, the delay is taking its own time. So the count value is 7 right now. Count value is 8, 9. So this will keep on running for 5 lakh times. So rather running this for such a long time, what we can do is we can pause the program and resume and run the program in one go. So now you can see the LED is blinking, and whenever you pause the program, you will be able to see the program is paused either in this loop, for loop, or might be possible you will be able to see the program will halt in this. It will be very rare to pause the program in either this command or this command, because most of the time microcontroller will be busy in the delay loop. Let us run the program again and pause. You can see, run the program and pause. So anytime these two lines, this particular function and this particular function will be executed in some nanoseconds, because the clock is running at 16 megahertz, and then we'll be spending most of our time in the delay loop. This is called polling. We will discuss about it in more depth in the coming videos, and we should avoid polling in our microcontrollers program, because most of the time is spent in this function, which is considered to be a useless function. Rather, we can use another alternatives to make the microcontroller free from these kind of functions and utilize the resources in a more optimal way. So click on this and you can see the LED is blinking. You can stop the debugging here itself and done. Second way is to load the program directly by using this option, flash option. Click on that, and in this case we will not be able to check the effect of each and every line of the code, because now the code has been loaded and the microcontroller is running. So we don't have the facility to check the effect of each and every line we have written in the program by using flash option. Anyway, we will discuss about these features of CCS or Code Composer Studio in the coming videos. So in this video we have seen how to provide clock to the port, configure the port or the pins as an output pin, how to configure the pins to make them high, how to make a function to make a delay, then make the pin low, and then again generate the delay. All these functionalities we saw, or we developed the program using TivaWare. With this, I would like to end this video here. If you have not subscribed my channel, then I would request you to subscribe the channel. If you have any suggestions or comments regarding this video, then please post your comments and suggestions in the comment section. Thank you and have a nice day.